We are a consortium of Earth observation specialists working for the European Space Agency.
The framework in which we operate is twofold. The first guiding principle is the United Nations Sustainable Development Goal 11. Make cities and human settlements inclusive, safe, resilient and sustainable. The second framework is the Project Implementation Strategy in international financing institutions like the World Bank and other development banks.
Our aim is to extend and improve the use of satellite data for the monitoring of indicators in order to reach Sustainable Development Goal number 11. We also want to facilitate international development work in a globally consistent manner by using Earth observation data and methods.
We have covered 32 cities around the globe with a total of more than 510 products and 11,000 square kilometers mapped. Our basic products comprise status and evolution of urban extent, as well as land use and land cover and its change over time. More specifically, targeted maps include slum maps, maps of open and green spaces, building footprints and heights, infrastructure, as well as hazard and risk maps. Based on these maps, we generate spatial analytics and the before-mentioned indicators for SDG 11.
These tools are very much relevant because they provide evidence.
In general, the preparations of bank operations take several years, but in these cases, it only took around 6 to 8 months for the preparation, thanks to the whole analytics, maps, and data evidences. The best part is that it was helpful to communicate with various stakeholders on the ground.
I want to introduce now our speaker of today. She's Amelie Prostzeit from GAF AG in Munich, in Germany. She's a technical remote sensing expert, and she will tell you more about improvements developed in master plans. She will give you a short objective of the training, some products we have developed within this project, what are the background for this use case, and then the example use case in Tanzania, and then conclude. Okay, and with that, I would like to give the floor to Amelie. I'll make you presenter.
I'd like to give a short overview on the structure of this webinar. I start with the objective of the webinar and give a short background introduction. Then I introduce the World Bank planning study in Tanzania and describe the achieved results and analytics, and close with the conclusion. At the end, you can ask all your upcoming questions, or well, you can already ask them in between and we can answer them at the end. The overall objective of the training is to show the usability of EO-derived geospatial products and analytics for analyzing the effectiveness of urban master plans. Herefore, satellite data is used to extract urban planning products like land use, land cover maps, transport network, urban population change, or urban green area assessment as examples. In a follow-on step, spatial analytics can be extracted from these datasets. These products can then be compared with the existing urban master plan of a city and support the quantification of the differences between the planned and the actual urban development in a city. Before we start with the example use case in Tanzania, I like to show which E04SD-Urban products are available, why urban master plans are needed, and why EO data can support the planning process. All these products here, which you can see on this slide, like urban green areas, transport network, population distribution, or the more advanced products like landslide risk or flood risk assessment or terrain motion assessment, are produced based on very high and high resolution satellite data. The data is in a first step pre-processed. This means that all atmospheric influences were minimized and the image is geometrically corrected. Based on this image, and with the help of ancillary data, a semi-automatic classification in the core and peri-urban classification is conducted to generate the baseline land use land cover classification. Based on this classification, a series of derived products can be produced as highlighted on the slide. With this, I'd like to give a short technical background on urban development. We all know that urbanization is increasing rapidly, especially in developing countries. In 2008, the number of people living in urban centers worldwide has for the first time surpassed the number of people living in rural areas. It is estimated that by 2050, the percentage of urban population will reach nearly 70%. This is leading to several problems in urban areas, like the increased development of informal and unplanned settlements, inadequate basic services like no running water, power, sewage, or waste disposal, urban development on land vulnerable to hazards, like city governments are very often underprepared to meet the challenges of increased vulnerability to these climate-related hazards. The level of productivity in a lot of cities is low by global standards, and traffic congestion and expansion of informal economy is constraining the potential economic growth of a city. In order to adequately address these stresses, several local, national, and international programs were initiated, some already years ago, to address these stresses. The main international policies are, for example, UN Habitat, Urban Agenda, or the SDG Goal 11. The main international national programs are GPSC, ESCI, ICLEI, 100 Resilient Cities, Cities Alliance, and also many more. Further, most cities also have national urban policies intending to achieve a more economically, socially, and ecologically growth of the city in their country. And on the local level, most cities also had and still have master plans to plan a more detailed sustainable growth of their city. But why can the aim of different policies, programs, and urban master plans not be achieved, and most cities in developing countries still grow unplanned? Within this webinar, it is of course not possible to answer this question. It's too complex and also too city-specific, but we can show a tool which helps to analyze and find topics which did work in a city and which not. The tool I am referring to is the use of very high and high-resolution satellite data. Within the Technical Assistant Project Planning Study, Impact and Effectiveness of Urban Planning on City Spatial Development in Tanzanian Cities, a project of the World Bank, E04 products generated within the E04SD-Urban project were used to analyze the impact and the effectiveness of master plans for so far 5 Tanzanian cities, namely Arusha, Dodoma, and Kigoma, as well as Mwanza and Mbeya. These 2 cities, Tanga and Mtwara, will follow this year. To give a short background on the Tanzanian cities, Tanzania has a rapidly growing urban population. 5.4 million people were added to urban areas with an average growth rate of 5.2% between 2002 and 2012. The employment in these secondary cities is still largely dependent on agriculture and informal service industry. All cities show monocentric development patterns leading to negative externalities such as difficulties in accessing inner city, traffic and congestion within the CBD, high transport costs, air pollution, and a few more. The study seeks to enhance the urban development agenda and inform policies and development strategies of cities in Tanzania through gaining further insight on the urban planning system and the development processes and the effectiveness of master and detailed urban plans. The study also seeks to assess the tools available to urban practitioners for the implementation of adopted and new plans. Therefore, within the study, urban master plans were compared with the E04SD-Urban Products to assess the impact and effectiveness on the actual urban development. On the following slides, results of the study are presented for the city of Arusha. Before I start with the exemplary results of the study, I like to highlight important topics for urban planning. On all these topics, I show examples in the following slides. Important topics are the land use and land cover distribution and change, planned versus unplanned settlements, the transport infrastructure network, comparative analysis between existing master plans and the actual land use land cover, the urban growth assessment, as well as the assessment of urban growth patterns, like how fragmented or continuous the city grew, and the calculation of different special metrics to quantify urban growth. All these topics can be mapped and calculated with the E04SD-Urban Products, and with this slide and the next slide, I'd like to show examples for these topics. So on this slide here, we see the land cover distribution and changes in and around Arusha. The map visualizes the 4 change classes: urban densification in blue, urban residential extension in red, other urban land use extension in purple, and changes within natural and semi-natural areas in green. The map shows that the residential densification is more dominant in the peri-urban zone, like the blue color, while the extension of residential areas is more dominant in the closer to the core city. And the bar charts on the right further visualizes these 4 change classes. This map here shows all residential areas in the inner city area. The classified polygons visualize the change in planned, here highlighted in purple colors, and unplanned, highlighted in red colors, settlements in Tanzania. The term planned settlements describe residential areas where the houses are oriented in the same direction, similar in size and shape, and have a well-defined road network, often in a grid pattern which provides almost direct access to every house. For unplanned settlements, houses are not oriented in the same direction and streets, if existing, are curved, small, and appear to have been constructed in an ad hoc manner, so no distinct pattern is visible. Also, not every building can be reached by a road. This definition, which is important to note, is only valid for Tanzanian cities. As you can see on the map, on this change map, that the unplanned settlements increased much more than the unplanned, highlighted in bright red, increased much more than the planned settlements, which are highlighted in a brighter purple color. In 2015, in Arusha, more than 70% of the residential areas are actually unplanned, and it's probably most likely that it's going to continue in this way than the other way. This slide here shows the change in the transport network of Arusha. The image on the left visualizes the local roads in gray, the collector roads in yellow, and the arterial roads in orange in 2005. The image on the right visualizes the denser road network in 2015. This product can be used for further special analyses, such as accessibility analysis to job centers, school, hospitals, to open to public transport stations, or to green areas, or to any other point which is of interest. The comparative analysis which now follows was conducted within the frame of the urban planning study for Tanzania. The analysis is also based on E04SD-Urban Products. In this study, existing city master plans were compared with the mapped land use land cover product prepared within the E04SD-Urban project. The level of land use and land cover conformity is here used as one of the proxies to evaluate the degree of impact and effectiveness of master plans and detailed plans. The following maps show a land use and land cover conformity analysis performed for Arusha. So this first map here on the left side shows the master plan of Arusha in 1985. The orange color highlights the residential areas, and the yellow is agriculture. The next map is the mapped land use land cover classification of 2015, mapped within the E04SD-Urban project. And the color coding is the same, so orange is also again residential and yellow agriculture. And you can already see the difference between both maps. The last map demonstrates the changes between both maps and therefore highlight all areas which did not develop as planned in 1985. The changes are also visualized in these bar charts. Like the image on the right is the same as on the slide before. And this bar chart, the first one, compares the land use in 1985 with the land use in 2005. The second compares the land use in 1985 with the land use in 2015. The classes on the left represent the land use classes from the master plan in 1985. The percentage, which is here on the x-axis, they give the land use land cover classes in 2005 and 2015. This means that, for example, in 2015, by looking at the residential class, only about 20% of the 1985 planned residential area actually became residential area, and about 70%, which is here in light green, remained agricultural land. The comparative analysis was also performed on a smaller scale. Here on this slide, you can see a detailed plan of an area in Arusha in 1997, in 2015, and the change between both years. The bar chart shows that 75%, it's again the classes on the left show the classes in 1997, and the percentage on the x-axis give the 2015 classification. The bar chart shows that 75% of the originally planned residential areas really became residential areas. About 20% became commercial areas, and about 5 institutional and cemeteries. Further, the urban growth was also analyzed for Arusha city. While using EO data to assess urban growth, it is possible to quantify the urban growth extent. It is also possible to define the urban growth pattern like edge, infill, leapfrog, and linear strip development. And also to define the growth texture, meaning if the city grew in a fragmented or more continuous way. In the graphic on the right, you can see the impervious, is the build-up area of Arusha from the years 2000 to 2015. And you can see that the build-up area or the urban extent of Arusha grew constantly and grew from 57 square kilometers to 130 square kilometers. This slide here visualizes the urban growth pattern of Arusha. You can see on the left side different leapfrog islands developing. You can also see a linear strip development along the main arterial road leading to the east, and different edge and infill growth around the already existing build-up areas. Now I like to show a few more special metrics to analyze urban development. One interesting analysis is the average distance to jobs, to urban green areas, or to public transport stations, or to any other points which are of interest. The purpose herefore is to measure the reachability of something. In this example here, from residential areas to potential job centers. The convenient distance of 500 meters, which we used, is based on a definition from the Sustainable Development Goal 11, and here from the indicator 11.2.1 on public transport accessibility. As input data, the land use product, or if available, building footprints were used. The output data is a map visualizing the distance from each building to potential job areas. This map here shows Kigoma and other Tanzanian cities. And so the magenta colors, the magenta polygons, they are potential job areas. Green, yellow, and red highlight the distance from each building to potential job areas. And you can see that in Kigoma, most buildings are within a convenient distance to these areas. Another example is a road density analysis per settlement type. The analysis was conducted on 3 Tanzanian cities, on Arusha, Kigoma, and Dodoma. The first graphic shows the total area of planned and unplanned settlements in the 3 cities for 2 dates, always for 2006 and 2016. As you can see in the graphic, the area always increased from 2006 to 2016. The second graphic shows the distribution of planned versus unplanned settlement areas, again for 2006 and 2016 for all 3 cities. So on the left side are the unplanned settlements, and on the right the planned settlements. In Dodoma and Arusha, the amount of unplanned areas is significantly higher than for Kigoma. In Kigoma, it's about the same. It's about the same area. The third one shows the road densities in unplanned and planned settlements, and it visualizes that the road density is higher in planned settlements and always in 2006 and 2016. With this, I come to the end of the webinar and like to quickly summarize it. Many developing countries are trying to improve the quality of their master plans. Geospatial data can support this endeavor. As shown on different examples in this webinar, EU-derived spatial datasets can show the actual and historic state of a city. Further, the E04SD-Urban Products have a very high accuracy, with an overall accuracy bigger than 85%. The case study presented on Tanzania illustrates some of the main benefits of using geospatial data for urban planning. The datasets allow comparative studies with existing master plans, for example, the calculation of the amount of fragmentation and compactness of a city, or different urban growth characteristics. And with this, I'd like to thank you for your time.